So today what we'll be doing is we're going to take a look at the trigonometry for acute triangles. Trigonometry can also be used for acute triangles. Triangles where all the angles are acute. Angles that are acute means that they are less than 90 degrees. Now, with acute triangles, there's no hypotenuse because there's no 90-degree angle if you think about it. When we talk about the sides, we say every angle has an opposite side, and every angle has a capital letter assigned to it, and then every side is all labeled as lowercase. So this one B is referring to this opposite side, little b. This C is referring to this opposite side, little c. So basically the capital letters represent the vertices or the angles for each corner, and the lowercase represents the sides of the triangle. Now, today we're going to take a look at the sine law. Now, the sine law says that the ratio of the side over the angle, or the angle over the side, is the same for all sides. So, this one here is to solve for sides. So this equation here is to solve for sides, which means when we're using it, we're using usually just two of these three together to solve for one unknown side. So as long as we know two angles and one of the sides, we call it the sine sausage, which is what this is. So I actually circle the appropriate sides, and when I have one side an angle, that means I have my sine sausage ratio, which will allow me to solve for A or big A, doesn't matter. Now the other side, the other equation we have here is to solve for angles. So if we're solving for angles, we always start with sine of A over A, or sine B over B equals sine C over C. So let's move on to our problem. The first two problems are going to be looking for sides. So let's go and do this. Now, like I said before, we're always looking for our sine sausage. This problem here says we're looking for side A. So the first thing that we're going to do is we're going to look for sides and angles that are pairs. So this is my first sine sausage. And then for angle A, there's side A, which is all the way over here. So I'm going to call that little a. Now, when we do our calculations, we're going to put the stuff that we're trying to solve on the right side. Now remember, since sine law is just the ratio of the side to the angle, since we're looking for the side starts on the top. So we get A over sine of big A is equal to, well, we've got 12 over sine of 62. Which gives us A over sine of 51 is 12 over sine of 62, which all we're going to do, this sine of 51, we're just going to move it up to the other side of the other side. Since it's division, it means it's going to be multiplication on the other side. So we get 12 sine 51 divided by sine of 62. So that is A. When we compute, we end up with A is equaling 10.4 centimeters. Let's move on to the next problem. Now remember, we have to find our unknown angle. Our unknown side. So we're looking for side R here on this problem. Now that we're looking for side R, I need this angle. I need this angle right here. To find R, we're just going to say this. Big R is equal to, you guessed it, 180 degrees minus 49 minus 60. So that finds the angle that's going here, and that final angle is 71 degrees. Now I'll just write that in. So now we're looking for our sine sausage. So we're looking for a side and an angle that are filled in, and we're looking for R with its appropriate R angle. So now that we have our sine sausage, we can do our calculation. So we're looking for R. So R always starts on the top, since that's what we're looking for, and it's divided by the sine of 71. So let's do that, which is equal to 16 over sine of 49. So we get 16 sine 71 over sine of 49, because if you think about it, sine of 71 is on the bottom and we're moving it to the opposite side, which means since it's division on the left side, it's going to be times on the other. So we get R equaling this, which gives us R being 20.6 meters. Now for our next problem, we're going to start looking at finding angles. Just like before, we find our sine sausage. So just like I said before, we're going to be looking for angles and sides which match. So these two here match, and these two here match. So we're looking for A. So we're going to write sine of A over, well, A's a matching side is 38, which is equal to, well, 16.5. 16.5 is on the bottom, so it's sine of 24 divided by 16.5. Now what we have to do, in order to get sine of A by itself, we're going to move the 38 up to the top of the other side. You'll notice a pattern. So we get 38 sine 24 divided by 16.5. Do our calculation, we get sine of A equaling, sine of A is equaling 0.878478 ... and when we do sine inverse, i.e. finding the answer, A equals sine inverse of 0.8478, you get an answer of the angle being 64 degrees. And now for our final problem of the day. Determine the measure of angle Z. Yes, we are in Canada. We say Z, not Z. So the first thing we have to do is we have to find our matching angles and sides. So these two are the sine sausage for X. And we're looking for angle Z, but we're going to have to find, we don't have one for Z, so we're going to have to find Y, since Y has its own matching value. So let's start with that. So let's find sine Y. So sine of Y over 13 is equal to sine of 55 divided by 12.3, which is, well, remember the 13 moves up to the other side, so we have 13 sine 55 divided by 12.3 is sine of Y. So now sine of Y, when we punch in all the stuff that's on the right side of our equation, we get 0.80368. And when we take the sine inverse of that, we find that Y is equal to 59 degrees. When we round to the nearest degree. And then finally, we use, in order to find the final thing. So notice I have 59. I'm going to write 59 in my triangle for y. So now that I know that, I want to find z. We're going to use the interior angles of a triangle. IAA of a triangle means that z is equal to 180 minus 59 minus 55, which ends up being 66 degrees. So z in this case is 66 degrees. Your homework for today is as follows. Page 249, 1 to 4. This is a simple set of problems. Try it out, see how it works.